Hi class, in this video we're going to be talking about representing data and we're going to go over four methods. The first method is going to be a line graph. So a line graph is really good for showing continuous data and changes or trends over time. So for example, in this example we have plant height, where height is the y-axis and number of weeks is the growth, so that's time. So in this case for time, I have my title as weeks, and then that's the x-axis, and then my y-axis title is going to be for height in centimeters, and then I have an actual title. And notice how I also have these numbers going up in a consistent pattern for the x-axis and the y-axis. So all of these need to be displayed for a line graph, and then I have my line here. Now for a pictograph, this is representing data with pictures. So here I have a scale where it says one apple, or the picture of one apple represents 10 apples, right? So we use this. So instead of drawing 10 apples, let's say for Fuji apples, I'm drawing 4 apples, but each one represents 10. So that means I sold 40 apples instead of selling 4 apples. Now, if I were instead to say one apple picture represents 1 apple, then I would have to draw 40 apples, but then that would be really long. So I shortened it by saying one picture of an apple represents 10 apples. So now you can see here, it's really good for, I guess, showing simple data comparisons using pictures and symbols. And it's good for a young audience because, they like pictures. The next one we're going to talk about is called the bar graph. So this is like the evolved version of the pictograph. So basically what you have here is you have a x-axis title, a y-axis title. You have the x-axis here, which shows all of the different types of apples. And then you have the y-axis here, and then your title, right? So this bar graph shows the same thing the previous one showed. So for example, Fuji apple, instead of, you have to actually count this. So one apple represents 10. So that's 40 apples here. Here I just state the number of apples, and I can just see that it's 40 right away by looking at it. So this one, it doesn't have pictures, so it's less child friendly, but it's a way to compare data similar to the pictograph. The pictograph, the flaws would be, like, notice here you have, like, for Red Delicious, it shows a picture of one apple and then what looks to be half an apple. Like, I could interpret this right here as 5 apples, right? But what if it's cut in a really weird way? Like, how would I represent 4 apples or 3 apples, right? Then it gets a bit tricky. So it's better to compare using, when you have like quantities like that, a bar graph, because you can actually take a ruler between, let's say, an interval of 10 and 20 and then determine something like what this would be. In this case, this would be 15. Now, a circle graph is the last one we're going to talk about for the method. All you need is the categories. So, for example, history, sports, teen romance, etc. Those are the categories. But then you also need the percentage next to the category. Now, the percent sums to 100%, right? So it adds to 100%. So notice if you add 10%, 13%, 20%, 23%, and 34%, all of these should add up to 100% because the entire pie or circle graph is 100%. It also has a title, which is good. And it has one more thing that's really important, which is this here. It tells us the number of books in total. So we need to know the total so we can find, using the pictograph, for example, how much of the total books is history. So then we would take 10, for example, right, for history. So let's go here. Let's go history. I would take 10%, which is actually 0.1, and then I would take 0.1 and multiply it by 3750, the total, to actually get the number of books, right? So in this case, 375 books are history books that have been signed out. So if I don't have the total, I couldn't do that. So that's one thing that you definitely have to have for a circle graph.